Alright, hi everyone, welcome to my YouTube channel, CTF Electrons. So this video is obviously a continuation of the previous one. Now, since we've talked about we've talked about management, we've talked about principles of management, we've talked about functions of management. Now we can go to engineering management, not just management, not just only management. So once you hear engineering management, we've been talking about management, right? So therefore, engineering management now is what? A specialized form of management. It's still management, but it's a specialized form of it. That is concerned with what? The application of what? Engineering as a result of what? Unique personalities and technical nature of engineering. So we are applying management skills to engineering, okay, or doing a management as an engineer. Now, decision making in this case now is the process of what? Identifying and choosing alternative courses of action to meet demands of the situation. That is, an engineer manager must follow a specific procedure to determine the best solution to a problem. And I think we've listed those things out in this under decision making. Yes, we've done that. We've listed that in the previous video. Okay, so but what are the techniques used in decision making? What are the techniques used in what? Decision making. Notes. We have qualitative evaluation and what? Quantitative. So for qualitative, what we're actually doing, we are using intuition and a subjective judgment. That's what we use to evaluate alternatives. But for quantitative, we are using technique. Now, the following are, we have qualitative and what? Quantitative evaluation. So, but what our lecture focused on was this particular one, qualitative evaluation, which has to do with what? Inventory models, queuing theory, network models, which we are going to focus on. Okay, forecasting, regression analysis, simulation, linear programming, sampling theorem, statistical decision making. But we are going to focus on one, which is network models. So that's what we have here, network models. Before we talk about network models, I want us to talk about this guy here, project management. Okay, or let's hit the network model first, since it's already linked. So for a network model or network models, it's a model which large complex tasks are broken into smaller tasks that can be what? Managed independently. Instead of working with the whole thing, you break it down, manage it gradually, okay, independently. So it is a network comprising a set of what? Acts meaningfully connected through nodes. I'll show you what the acts and nodes mean to analyze and solve scheduling and control issues. The network model is an advanced version of what? Gantt milestone charts. For the Gantt milestone chart, I will show you right here. Yes, under project management. Now, engineers and projects, they're like, let's say 5 and 6. Engineers and projects, oh Bob. So as an engineering manager, what you manage most times is projects. Of course, we manage people also, but for now, let's talk about engineering manager managing what? Project management. So, but first of all, what's a project? A project is a new and temporal. Oh, it's temporal because a project has a beginning and has an end. So temporary. A project is a new and temporary endeavor consisting of what? Interrelated activities executed in a specific order as a precedence relationship to achieve a unique objective. So in order to achieve a unique objective, which is your project, there are sub activities, combination of activities that are interrelated you have to complete in order to say, oh, I have completed a project. So the distinct characteristics of a project includes uniqueness, specific nature, temporary in nature, interrelated activities, resource allocation, constraints, stakeholder satisfaction, and what? Defined outcome. This is the whole idea of a project. Now, to manage the project management involves what? Planning, organizing, coordinating, monitoring, and what? Controlling interrelated, time bound. Time what? Bound. You don't do projects like forever. Okay, it's time bound. So the activities in the project are also time bound. Okay. Now, the search for effective project management tool has led to the development of various techniques, broadly classified into what? Bar charts and what? Network models. Are we together? So, since we need an effective way to manage projects, there are two main methods, which is the bar chart model and the network model. So the network model is what we are going to talk about. The bar charts, we didn't really say much about that. So the network model, which I defined earlier in this video. Okay. Now, the two prominent network analysis techniques which were developed between 1956 and 1958, 2 years apart. 2 years apart. So the two techniques are what? The project evaluation technique, PERT, project evaluation project evaluation review technique, and then the what? Critical path method. Okay. Again, we are going to focus on the critical path method. It's as if we are zooming in into a particular technique. You see this example I showed you guys in the previous video also. This example, okay? What the technique used here, we are already zooming into that particular technique. Okay, so I said we focus on the network model, right? And inside the network model, critical path method. But first of all, this project evaluation review technique, PERT, was created by US Navy for Polaris missiles program, while the CPM was developed by EI DuPont de Nemours and Company for construction project. You see this one, this CPM has to do with construction projects. This PERT started with what? War. Okay, missile program. So for the CPM was developed for what? For construction projects, and was later improved by this man association. Okay, so the primary difference is that CPM uses what? Deterministic single time estimates, whereas PERT uses what? Probabilistic, which is based on multiple time estimate for activity duration. Now, this network model, this is a tool, or this is the technique we are going to use in the example. Okay, but note that a project has life cycle. Since we have been saying that project is time bound, it's not forever, it means that there are stages a project goes through from inception towards completion, and it's referred to as what? Project life cycle, PLC. A typical project consists of 4 phases: conceptual phase, planning phase, execution phase, and termination phase. Of course, you get the idea. Conceptualization phase. Then you do what? You plan. Are we together now? And then you execute the plan. After execution, then the project is what? Completed. Then you can say it's what? Terminated. Okay. Exactly. Now, methods of representing projects and guidelines for network construction. Back to this one. I said we are going to use the network model as the technique for what? Project management. Okay, I said that before. That's why we have a slide for it. So since we are going to use the network model, what method are we going to make use of? So the method of representing projects and the guidelines for network construction. Now, there are two what? Methods. Of course, we'll focus on one. I'll tell you the one we'll focus on, okay? So there are two methods. Activities on what? Arrow. And the other method is what? Activities on nodes. First of all, what are arrows and what are nodes? Look at this. So This, excuse me. Okay, yeah. That, and this is an arrow, obviously, obviously, and this is what? A node. Exactly. So if you put your activity on top of the arrow, activity here is what? Activity on arrows. Activity on what? Arrows. If you write your activity here instead, let's say you write your activity here instead, it's what? Activity is what? Activities on node. Are we seeing the difference now? So that's for that. So we are using the what? Activities on arrow. That's the one used in class, so I'm just going with that. Okay. Now, the following are guidelines for what? Network construction. So a network model must have a unique starting point. It must have a what? A unique starting point. We can have arrows coming from it, but not going into it. What do we mean? I think I have the example here. Where are you? Where are you? Where are you? Where is that example? Okay. Yeah, this is it. Yeah, this is what I was looking for. So this is the beginning guy. You can see arrows coming out of it, but there's no arrow going into it. Okay. So back to, yeah, this. So now for end node, that's the last node, we can have arrows going into it but not out of it. Okay, then the number of events begins at the start from left to right and from upward downward direction. Look at it here, from left to right. Are you seeing that all the arrows are going from left to right, left to right, left to right, left to right? So if our number, will say number one, node 1, node 2, node 3. Let me quickly say this. We are going from left to right as we number, and from up to down, meaning we are supposed to have here as 3 and here as 4. But we were told in class that just for example's sake, that's why we numbered 3 and 4. But in case of test or exam or whatever, we should number 3 before 4. Okay, so back to this. All right, now merge events. These are events that have 2 or more arrows merging into one. 2 or more arrows merging into one. Look at it. This is one, Abi. Arrow is going into it, another arrow is going to it. So this is a merge event because 2 or more arrows is going to it, but this is just 2 arrows, so it's a merge event. Let me say the next one. Burst events. If you have 2 or more arrows going out of one, you say it's a burst event. So this is a burst event. Okay, 2 arrows going out of it. This one is also a merge event. Okay, I think we can say this one is a burst. This one is a burst event now because you have 1, 2. Okay. Now, duration. I've already mentioned burst events. So duration. This is the mean average of estimated optimistic time. That is TO, optimistic time. Most likely time, that's TM. And what? Pessimistic time, that's TP. TE is what? The estimated time. And estimated time equal to what? Estimated time equal to what? CO, which is optimistic time. This I simply means what? The particular activity. Okay, so optimistic time for that activity plus 4 multiplied by the most likely time of the activity plus the pessimistic time of the activity, all divided by 6. You just have to memorize 4 and 6, just so that it's this plus this plus this. The center one has plus all over 6. Exactly. So now let's go to let's work an example. Okay, so all we've been saying all this while, now we finally come back to our example. Are we ready now? Good. So the example is this. You are an engineering manager. Okay, so there's a project to create a lift irrigation facility. Don't mind the big names. A project to create a lift irrigation facility on a farm with the following assumption. Now, the competent authority has approved the project. Hence, project evaluation starts with what? Site selection. This, my guys, is an activity. Okay? So, in your solution, that should be on the table. Look at this table. That should be an activity. Look at it. Forget about all this side. I will explain them. Okay? Don't worry about this side. So, serial number and activity. So, site selection, that's an activity. Back to the example. The next assumption is what? Note, all these are part of the question, guys. All these are part of the question. Next assumption: irrigation will come from newly dug well. Meaning we should do what? Dig well. So that's the next activity. Digging well or well digging. Okay. Next assumption: field channels from the well will be laid after the well is dug. That means field channel will be laid, abi. So lay field channels. Next activity: laying of field. Okay. So next assumption: a suitable pump will be procured and installed for lifting water. So procure pump. That's the next activity. Are we feeling? Are we seeing it? Next one. Next assumption: the pump and other specification for the pump are based on groundwater prospecting data before digging. Okay, there's nothing for us there. The pump and other inputs will not be procured until the site is selected. Bear this in mind, very important, because there's something called precedence. Precedence meaning which activity come before which activity. So this assumption is important to know. Specification for the pump are based on groundwater prospecting data before digging. Before what? Digging. So then the pump and other inputs will not be procured until the site is selected. Then the pump will be installed after digging the well. So install pump is also an activity. So you now put it there. Installation of pump. And then the last thing, a test run will be conducted after installation. So test run, that's the last activity. Test run. So this code just means instead of writing selection of sites in your network, that diagram, instead of writing all these many stories on the diagram, write letters that represent each story or each activity rather. Are we getting it? So this column called code just means you use letters to represent activity. A, B, C, D, E, F, as simple as that. Are we clear? Now, the last thing I want to show us here is this one. Note that optimistic time, TO, most likely time, TM, and pessimistic time, TP, are given. Okay? So, this thing now, we are not calculating for all these values. You see them, TO, TM, TP. We are not calculating for any of them. They are what? Given. Exactly. So you just put them in the table like this. This precedence will fill it in, and this answer will fill it in. Then we'll now use this diagram to draw our network. Exactly. So the steps include what? We're in the solution now. The steps include what? Prepare the list of activities, which we have done already. Okay? And then what? Define interrelationship between activities. That means precedence. Which activity come before which activity? So we can do that one right now. Okay? Let's do that right now. So in order to do that, what we are going to consider is this. Now, before site selection, what comes before site selection? Before you select the site, what happens? No activity. There's nothing. Okay? So we want to start. We've been giving go ahead, Abby. So we start with site selection. Nothing comes before site selection. So it takes first precedence, nothing comes before it, so nothing there. Then for digging of well, before you dig well, you have to select your site. Meaning site selection takes precedence over digging well. Are we seeing how the thing is now? Then laying of field channel. Before you lay field channel, you have to dig this well. Are we following? So digging of well comes before laying of field channel. Are we together? Then before procurement of pump, well, for procurement of pump, before you even select the site, you can get pump, or you select the site. At least you are sure you have a place to do your project. You are sure you have the place for the project first. Then you now, okay, now since I know I have a place for the project, I have the site, I can go and buy pump. So this one comes first. Okay, site selection comes before procurement of pump. Exactly. Then installation of pump. Of course, you have to do what? Dig the well before you install your pump. That means B will come first. You have to dig well first. Okay? But remember that this installation of pump, you still have to buy the pump. You still have to procure the pump. Meaning you have to dig the well and then procure the pump before you install the pump. If you dig the well only, no pump, then you cannot install pump. If you procure the pump only, no digging, there is no place to install it. So you need to dig, have a place to install it, and then what? Procure it, have what to install. So these two activities must happen before this activity will happen. Exactly. Please let me know in the comment section if you are following. Then before you test run, oh come on, before you test run, you must have done what? Installation. You must have done installation, and you must have what? Lay the field channels. Lay the field what? Channels. Okay, so you must have what? Lay field channels before you test run. But of course, before laying field channels, B will come, so we'll just write this C. Oh, let me go alphabetically. C, letter C, whichever one is still the same thing. Okay, so we have our table. Precedence is now filled, so we have done this second step. Now the third step is what? Estimate activity time. Estimate what? Activity time. I said these values will be given. This 4 days. These values will be what? Given. Okay. Now TOA is for what? Activity A. Meaning for site selection to take place, the optimistic time they said for 6 and 14, right? So what you do is what? You bring those things to the formula. Remember the formula we wrote before. So 4 days for, remember the formula, right? Which is this. Okay, let me just write that in again, since before I go and look for the whole thing. So the formula is what? Is TO plus what? 4 times TM plus T what? P all over 6. So in this case now, our TO, we are talking, that's for event A or activity A. So it's 4 days, so you put 4 there. Then here is 6 days, you put the 6 here. Here is what? 14 days, you put 14 here. Just multiply this, add and divide by 6, you get 7 days. Meaning the TEA for here will be what? 7. Are we following? So we can even try that for the next activity, where we have what? 2, 3, 4. So this one now will be what? Activity B, right? So here will be B. Here will be B. Let me change all that. So here will be, let's put it that B, activity B, MB. Here will be B. So for B is what? What are the values there? 2, 3, 4. So we now have what? We now have 2, 3, 4. We now have 2, 3, 4. Here will be 2. Let me change here. Here will be 2. Here will be 3. And here will be what? 4. The 6 is constant. It remains. So when you do that division, you get what? You will get this answer as what? Where? Is this table not too far, guys? So you get here as what? 3. Are we seeing it? So you do that to the rest parts. The next one will be what? 15. The next one will be 7. And the next one will be what? 5. And the next one will be what? 2. Do your calculation, you will get those values. Okay? 3 days. That's for the first one. Okay? Then the next thing is what? Assemble activities in form of what? Flowchart to determine critical paths. Alright, so this is the solution, but we are not done. The solution continues here. Okay? Which I think we'll take in the next video, and I think it will be the last part. Okay?